A common question is why e? It seems almost random. A better question is why e to the x? E to the x is an important function in calculus and is more noteworthy than e by itself. So let's take a look at how we arrive at e. So the main property with e to the x is that its derivative is equal to itself. So if we have a term over here, we're going to have to add that term over here too. So let's start off with 1. So if 1 is in a derivative, x must be in the function too, since the derivative of x is 1. And we got that using the power rule. If we have s in the derivative, we're going to have to do the same process over again. It's going to be x squared over 2. And we get that because x squared has the derivative of 2x, and then if we divide that by 2, we get x. So again, we're going to be doing the same process. Here we have x cubed over 6, resulting in the derivative of x squared over 2, and we can see that for x to the 4th. And we can keep going until we get to x to the n over n factorial. So this is basically a generalization of all these terms over here. So here's n at 0, n at 1, n at 2, n at 3, n at 4. And just to recap, n factorial is basically n times n minus 1 times n minus 2 times n minus 3 all the way till you get to 0. So here we have x to the 0th power over 0 factorial, and 0 factorial is 1. So we're going to just be left with 1 since s to the 0th power is going to be 1. Here we have s to the 1st power over 1 factorial, and that's just going to be s. Here we have s to the 2nd power over 2 factorial, and that's going to be s squared over 2, and so on and so on. So previously with polynomials, we saw that when we find the derivative of a polynomial, it's always going to be a lower order polynomial. But with exponentials, it's a little bit different. We find that the derivative is always going to be proportional to the original function. So we can kind of think of it using the idea of population growth, since it's exponential growth. So if we have 2 bunnies creating 1 bunny, and we have 50 bunnies in the original population, we're going to get an increase in 25 bunnies. So our growth rate here is 1.5, and we can see that the increase in population is proportional to the original population. Our increase in population is going to be dependent on the original population that we did have. So because of this, we can sort of define e as the one exponential function. All other exponential functions can be written in terms of e. So here we have e to the x with times the natural log of n equaling n to the x power. So say we have e to the x times ln of 2 equals n to the x power. And we're going to see that all exponentials have the same property of being proportional to the original function. And using that, we can derive a way of finding the derivative of these exponential functions really easily. So if we, taking the example of e to the x, if we had e for n, we have e to the x here, and when we take the derivative of it, we're going to be left with ln of e, which is just 1, times e to the x. So that's how we can sort of prove that the derivative of e to the x equals e to the x, and its derivative is directly proportional to e to the x since the proportion is just 1.